Hello everyone and welcome back to our channel. Today we're diving into one of the most fundamental functions in PySpark, the count function. Whether you're new to PySpark or looking to sharpen your data skills, understanding how to count rows and column values is crucial for data analysis. In this video, we'll explore different ways you can use the count function to get insights into your dataset, from simply counting rows to calculating unique occurrences and checking data quality. So let's get started and master counting in PySpark. Introduction to the count function. The count function in PySpark is a fundamental tool used for counting the number of rows in a data frame or counting the occurrences of specific values within columns. It is quite similar to the count function in SQL, allowing you to efficiently determine how many records exist in a dataset or how frequently certain values appear in a column. This function plays an essential role in data exploration, enabling you to quickly understand the size of your dataset or gain insights into the distribution of values. When applied to a data frame without specifying any conditions, count returns the total number of rows in the dataset, helping you understand the dataset scale. This is particularly useful for initial data exploration, where it is important to verify the completeness and volume of data before moving on to further analysis. Alternatively, you can use count in combination with other PySpark functions to count specific column values that meet certain criteria, such as counting how many times a particular category appears in a column. The count function can also be applied as part of an aggregation process. For example, after grouping data by a specific column using groupBy, you can use count to determine the number of occurrences of each unique value in that column. These help identify patterns, assess the frequency of categories, and provide a better understanding of the underlying data structure. Whether you need to count the total number of rows, count distinct values, or count occurrences after grouping, the count function is a versatile and straightforward tool for summarizing and analyzing your data effectively. Basic syntax. The count function in PySpark can be used in different ways depending on how it is applied. When you use count directly on a data frame, it simply returns the total number of rows in the entire data frame. This is useful when you need to determine the size of your dataset or verify the number of records after performing operations such as filtering or joining. Using count in this direct manner gives you a straightforward answer to how many rows are present, which helps in understanding the scale of your data. Another powerful way to use count is in combination with the groupBy function. When count is used after groupBy, it counts the occurrences of each group defined by the column specified in the groupBy statement. Essentially, the term is first grouped by the specified column or columns, and then count is used to determine how many records fall into each group. This is particularly useful for analyzing category data where you want to know the frequency of each category or the distribution of your data across different groups. For example, if you group data by a column such as region, applying count will tell you how many records exist for each distinct region. This kind of grouping and counting is a common task in data analysis and helps to reveal patterns and trends with the data state, such as identifying which categories are the most prevalent or how data is distributed across different segments. Overall, whether used directly on a data frame or in conjunction with groupby, the count function is an essential tool for understanding your data and deriving valuable insights from it. Why use count? The count function is a fundamental tool for understanding the size and scope of your data. One of the first steps in any data analysis process to get a sense of the overall dataset, and count helps you do just that by providing the total number rows in the data frame. This basic yet crucial information allows you to verify completeness of your dataset and determine if it matches expectations. Whether you are working with a small subset or a large dataset, Knowing the exact number of rows helps set the foundation for further analysis. Beyond understanding the overall size of data, count is also widely used for calculating frequencies and counts of specific values. It is especially helpful when analyzing categorical data to see how often certain values or categories occur. This type of frequency analysis can give you a deeper understanding of your data distribution, allowing you to identify patterns, trends, and potential outliers. For instance, if you are working with sales data, you might use count to determine how many transactions occurred in each region or how frequently a particular product was sold. The count function is also commonly used in data profiling, where understanding the distribution of data is essential for quality assessments. It is valuable for reporting purposes as it allows you to summarize data and present meaningful statistics. Whether used on its own to determine the total number of rows or combined with groupBy to see counts within groups, count is an essential part of the data analysis toolkit, providing quick and actionable insights into the structure and distribution of your dataset. Practical examples. 1. Counting total rows in a data frame. In this example, we are working with a PySpark data frame div that contains information about different individuals represented by two columns ID and name. Each row in the data frame represents a unique individual with an ID column for the unique identifier and a name column for the person's name. This structured data allows us to analyze and manipulate the dataset easily. To determine how many rows are present in data frame, we use the count function. The count function provides the total number of rows in the data frame, helping us understand the size of the dataset. This is particularly useful during initial data exploration as it allows us to verify the number of records and confirm that the data is complete. In this case, we call df.count to count the total number of rows in the df data frame. The result of the count function is stored in the variable row underscore count, which holds the number of rows in the data frame. In this example, there are 4 rows in the dataset, so the count function will return a value of 4. To make the output more user-friendly, we use the print function to display the total number of rows in a readable format. The message total rows 4 is printed, confirming that the data frame contains 4 records. This example demonstrates the simplicity and effectiveness of using the count function to get a quick understanding of the size of your dataset. Whether you're working with small or large datasets, count helps you easily determine how many rows you have, providing a foundation for further analysis. It is an essential step in data exploration to ensure that your dataset is complete and ready for further processing or reporting. 2. Counting non-null values in a column. In this example, we are working with a PySpark data frame diff underscore with underscore null that contains information about individuals with 2 columns ID and name. The ID column represents a unique identifier for each individual, while the name column stores the name of each person. The data includes some null values, specifically in the name column where one of the entries is none. This kind of data structure data is common when dealing with real-world datasets, which often contain missing or incomplete information. To determine how many of the values in the name column are non-null, we use a combination of the filter and count functions. We start by applying the filter function to the data frame to filter out rows where the name column is null. We use diff underscore with underscore null dot name dot is not null to keep only the rows where the name value is not null. This step results in a new data frame containing only the records that have a valid non-null value in the name column. Next, we use the count function to determine the total number of rows in the filtered data frame. By calling count on the filtered data frame, we get the number of records that have a non-null value in the name column. This count is then stored in the variable non underscore null underscore count, which holds the total number of names that are not missing. In this specific example, there are 4 rows in the original data frame, but only 3 of them have non-null names. Finally, we use a print function to display the result in a readable format. The output message non-L93 is printed, indicating that there are 3 rows in the data frame that contain non-values in the name column. This example illustrates how you can use filter and count to analyze the completeness of your data by checking for missing values. It is a common practice in data cleaning and quality assessment to ensure that your data is as complete as possible before proceeding with further analysis. 3. Counting unique values in a column. In this example, we are working with a PySpark data frame diff underscore with underscore null that contains information about individuals represented by 2 columns ID and name. The DAO column uniquely identifies each individual, while the name column stores their corresponding names. The data frame includes some missing values in the name column, which is not uncommon, especially uncommon in real world datasets that often have incomplete or missing data. To determine how many unique names are present in the name column, we use a combination of the select, distinct, and count functions. We start by using the select function to select the name column from the data frame. This step gives us a data frame with only the name column, isolating the values that we want to analyze. Next, we use the distinct function to identify and retain only the unique values in the name column. This helps eliminate any duplicate entries so that we only consider distinct names in the dataset. The distinct function is particularly useful when working with categorical data, as it allows you to easily understand the diversity of values present in a column. In our case, it helps us determine how many unique individuals are represented by their names. After identifying the distinct names, we use the count function to calculate how many distinct values are present. The count function gives us the total number of unique names in the name column, which is stored in the variable distinct underscore count. This variable holds the count of unique non-duplicate names, including the none value if it is present. If we use the print function to display the result in a clear format. The message distinct names 4 is printed, indicating that there are 4 distinct values in the naming column, including the none value. This process helps provide an insight into the diversity and uniqueness of the values in the name column, which can be helpful for understanding the dataset structure and ensuring data quality. Overall, this example demonstrates how you can use select, distinct, and count together to efficiently calculate the number of unique values in a column. This type of analysis is valuable when exploring categorical data, as it helps to understand the distinctiveness and frequency of different entries in your dataset. 4. Counting rows after grouping. In this example, we are working with a PySpark data frame df underscore sales that contains sales data for different items. The data frame has 2 columns, item and alias, where the item column represents the name of each item, and the sales column contains the corresponding sales value for that item. Some items appear multiple times in the dataset with different sales values, which is a common scenario when working with transactional or sales data. To determine how many times each item appears in the dataset, we use the groupBy function in combination with the count function. The groupBy item step groups the rows in the data frame based on the unique values in the item column, meaning all occurrences of the same item are grouped together. This creates distinct groups for each unique item, allowing us to analyze the number of records or rows associated with each item. Once the data is grouped by the item column, we apply the count function to calculate how many records exist for each item. The count function returns the number of occurrences of each unique value in the item column. This is particularly useful for understanding the frequency distribution of items, which can help identify trends by popular items or inconsistencies in the data. Finally, we use the .show method to display the resulting data frame. The output contains 2 columns, item and count. The item column lists each unique item, while the count column shows how many times that item appears in the dataset. For example, if item appears twice in the dataset and item appears twice, the count for both items will be 2. Item C appearing only once will have a count of 1. This example demonstrates how the group by and count functions can be used together to easily analyze the frequency of occurrences in your data. By grouping the data and counting the number of records for each item, you can gain insight into distribution of values and identify patterns which can be useful for inventory analysis, sales tracking, or other business related tasks where understanding the frequency of items is important. 5. Counting multiple columns. In this example, we are working with a PySpark DataFrame diff_sales that contains information about items and their corresponding sales values. The data frame has two columns, item and sales, where item represents the name of each product and sales represents the sales amount for that item. Some items appear in multiple teams in the dataset with different or repeated sales values, which is common in transactional or sales data that contains records of multi-sales. To determine how frequently each combination of item and sales occurs, we use the group by function to group the data by both columns item and TT. By calling group by item sales, we group the rows based on unique combinations of values in both the item and sales column. This means that each unique pair of item and sales value is treated as a distinct group, allowing us to analyze how often specific sales values occur for each item. After grouping the data, we use the count function to calculate the number of occurrences for each combination of item and sales. This gives us the frequency of each distinct pair, allowing us to see how many times a particular item had a specific sales value in the dataset. This type of analysis is helpful when you want to understand how often certain sales amounts are recorded for each item, identify sales patterns, or spot any potential anomalies. Finally, we use the .show method to display the resulting data frame, which includes three columns: item, sales, and count. The item column lists each unique item, the sales column shows the corresponding sales value, and the count column indicates how many times in that particular combination of item and sales value appears in the data set. For example, if item A with sales value 100 occurs once and item B sales value 200 also occurs once, the count will be 1 for both combinations. This example demonstrates how you can use group by in combination with count to analyze the frequency of unique combinations of columns in your data. By grouping by both item and sales and counting occurrences, you can gain insight into specific sales patterns and understand how sales are distributed across different items. This approach helps in gaining more detailed insights into the behavior of individual items and the respective sales transactions, providing a comprehensive view of the data set. 6. Counting all columns in the data frame. In this example, we are working with a PySpark data frame df_sales that contains sales data for different items. The data frame has two columns, item and sales, where item represents the name of the product and sales represents the corresponding sales value. This data might have some missing values, null values, which is a common scenario in real-world datasets. To better understand the data quality, it's important to determine how many non-null values are present in each column. To achieve this, we use the add function to perform an aggregation that counts the number of non-null values for each column in the data frame. We use a combination of count and call to dynamically count non-null values across all columns. The code snippet count call c dot alias c for c in diff_sales dot columns is a list comprehension that iterates over each column in the data frame diff_sales dot columns. For each column C, we apply count call C to count the non-null values in that column. Using alias C, we rename the resulting count to match the column name, ensuring that the output is easy to interpret. The add function takes the list of aggregated counts for each column and applies them to the entire data frame. This gives us a data frame with a single row that contains the count of non-null values for each column. Finally, we use the .show method to display the results. The output will have columns named after the original data from item and sales, with values representing the count of non-null entries in each column. For example, if the item column has no missing values, the count for item will equal the total practical for the rows in the data frame. On the other hand, if the sales column has any missing entries, the count for sales will be less than the total row count. This aggregation helps in quickly assessing the completeness of the dataset by identifying columns that may have missing data. Overall, this example shows how to use ag along with count to evaluate the quality of data by counting non-null values for each column in the data frame. This is an important part of data profiling and quality assessment, helping ensure that the data is sufficiently complete for further analysis or reporting. Using descriptive aliases for each column, the output is both clear and informative, making it easy to see at a glance which columns have missing values and how many value-added entries exist. Thanks for watching. I hope this video helped you understand the various ways you can use the count function in PySpark to simplify your data analysis tasks. Counting rows, identifying distinct values, and checking non-null values are all essential steps for effective data exploration and cleaning. If you enjoyed this video, make sure to give it a thumbs up, share it with your peers, and subscribe to our channel for more PySpark tutorials. Feel free to drop your questions or suggestions in the comments below. I love hearing from you. Until next time, happy coding and keep exploring the world of data.